What up, Mr. Chang? Rad, wow, you are first. Super quick. All right, let's see. I'm kind of curious actually to see what the turnout's going to be for today. We will see. Hey, Meenakshi. I'm feeling like it might be. I'm kind of in between on it. I feel like it might be a lot because it's for finals, but I also feel like finals are still a little ways away. It's a little early, but we will see how it goes. That must be a good feeling to be done with your finals at this point. That's pretty early too, but pretty legit. So, good for you. Successes? You feel like you did well? Let's get this party started. What's up, Arthur? Arthur Chan? I don't know if I've seen you before, man. You must have somebody else for bio. Welcome, welcome, welcome. What up, Arun? How long is it going to be? Probably... It's probably going to go past 9:30. Probably won't go past 9:30, that's my guess. I'm thinking 9:30. Hour and a half. What's up, Onslaught? You were going to watch a video lecture and you noticed I started streaming. Nice. Good timing. Good timing. So you're in Learner. It's funny, I was having a... Miss Learner called me a little earlier trying to get her live stream up and running. And so I checked and I saw I heard her conversation with me on the phone through her live stream because she was actually live streaming at the time she called me. It was kind of funny. Made me laugh. You know what? I might play Fortnite actually. I'm not really feeling Undertale right now. I haven't played Fortnite in a while. I could do that. Let me update it though. It's going to. I haven't played it in a little while, so it's going to need to update for sure. Or I could play Ultimate Chicken Horse. Actually, I forgot about Ultimate Chicken Horse. I forgot about that game. That game's actually not too bad. I could practice a little bit. Later, Onslaught. Have a good one. Yeah, of course, Arun. Anytime. This is what the stream is for. You can ask questions anytime. Shoot away. I will answer. I will answer your questions. Hey, Charby. Nice to see you. Slaya, what up? My dude. What is up? So, let me pull this bad boy up. Oh man, my leg. Stretching my knee. Alright, we got our first bio question from Arun. Which cells are the ones in the leaf that have the most chlorophyll? Those are going to be the palisade cells because they're the top layer of the leaf, right? If you think about a leaf, most of the sun hits the top. So you're going to want to have most of your chlorophyll in the cells at the top of a leaf because that's where most of the light is, so it can absorb it to do photosynthesis. Makes sense? But there, keep in mind there's still going to be chloroplasts in all of the cells of a leaf. There's just more concentration in those palisade cells, which form the top layer of the leaf. That is sad, Mr. Chang. 3 officers were killed in the line of duty this week. Is that number 3 meaning just in the Bay Area, or in California, or in the U.S., or what? What up, Athik? Is that how I pronounce your name? Athiksh? 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 Hopefully I'm pronouncing that name right. Hopefully. Arun, aren't there 2 types of palisade cells? Not that I'm aware of. At least not that we teach. We teach that there's palisade cells and then there's the mesophyll cells in the bottom, the spongy mesophyll cells. Those are really the only 2 layers that we really kind of talk about as far as the cells of the leaf. It's just 2 layers, the palisade on top, the mesophyll on the bottom. Oh, you're Jed in your bed. Nice. Okay, that's who you are. Now I know. Let's find some public games. Hey, there's a host called Stem Cells. That's relevant. I'll join that one. That's relevant. The canine? Oh, why do I always feel better? Why do I always feel worse for the dog? It's like 3 officers and a canine, and I immediately go, oh, the poor dog. Poor pup. Feed the raccoon. We're talking about pests this week. Oh, I got kicked from the game? Why? Got kicked. I don't know if Mr. Penev is going to play, Rhea. I feel like Mr. Penev is sick this week. He got a sinus infection, so he's been really sick lately. So I doubt he'll play. Yeah. Yeah, go ahead, ask your question, Arun. Just don't worry. Ask away. I'm just here for your questions. So Arun, this game works, it's like an obstacle course that you sort of build as you go along, and the goal is to see who gets through the quickest. So you can like pick items at the beginning to try and trap people. So like I'm gonna place this thing maybe like right here. See, it's hard to get up there. Oh, that guy did good. Set the sword. Stuck now though in that little hole. So Arun, what's up, Ansh? How are you? I don't know, Rhea, if he's coming tomorrow. That's a good question. I wouldn't count on it. He's probably just going to take the week off because he's pretty sick. So don't count on it. Arun, what are the two types of graphs that demonstrate population? The two types of graph that demonstrate population, typically we call it logarithmic and exponential. Logistic and exponential. So logistic growth is the one that has an S shape to it, so it starts off going up really steep and then it sort of tapers off and levels off. That's what a population will naturally do as it hits its carrying capacity, right? Which means as it hits the amount, as the population hits the max that that environment can hold. Exponential growth is when it just is before it turns logistic. Oh, I can't jump on the side of that thing. So basically you have two types, exponential and logistic. Yes, Ansh, you're correct. What up, Shervin? Shervin, what is the pathway of carbon through the carbon cycle? There's a lot of different pathways of carbon through the carbon cycle. It can go many, many different ways. It's not just one single way. There's a lot of different routes you could take. So if you think about the, I don't know if in your class, I'm not sure what teacher you have, but if you're in your class, you guys did the dice game, the carbon dice game, right? You could like jump around to a bunch of different places. And really could go any direction in a lot of different ways. So it's kind of, I can't really explain every single pathway, but we also did remember the little diagram that we drew? Like it had a little picture of a town and it had like a car in it and some trees, and we had to draw arrows and label them. That's a good indicator of the way carbon moves too. So let's see, I want to place this thing. Shervin, I'll pull up a, what if I pull up a, what if I pull up a, what I can do is I can pull up a what do I call it, a graph real quick. Not a graph, but like a diagram to show you. And we can maybe get a little bit of clarity on the different ways. So what you're going to want to do when you looking for carbon cycle, it's something simple like this is even pretty good. This diagram right here. It's very basic. There's more pathways than this, but it kind of shows you the general kind of idea of the different ways that carbon can go. So what you want to do is review all of the different connections in here. Ansh, how do glaciers trap carbon? Glaciers trap carbon because they're frozen water and it has little air bubbles in it. And not only is there carbon in the water, but there's carbon dioxide in the air bubbles too, and it gets trapped in that ice for a very long time. If the glaciers melt, it releases the carbon back into the atmosphere. But if it doesn't melt, it stays in there. So that's how it can trap carbon. What's up, Kelly? Oh, what causes kwashiorkor? I don't even know if I'm pronouncing that right. Kwashiorkor. That's malnutrition, usually due to lack of protein in your diet. So these are going to be people who get this are usually living in very impoverished conditions where their diet is they're very malnourished, which means that they're getting lack of protein usually, and it leads to things like edema, like swelling. So you've ever seen those pictures of the, you see very famished, like African children where they have those big bellies. That's from protein deficiency for the most part. It's called kwashiorkor. Kwashiorkor. Actually, let's get to the bottom of this. How do you pronounce this? Does it tell us how to pronounce it? Let's see.
Kwashiorkor. Kwashiorkor.
Kwashiorkor.
Kwashiorkor.
Kwashiorkor. Okay. Yeah. Yeah. But it's basically caused by lack of protein in the diet. Hey Tara. Arun, let me get to your question real quick. Does life in the ocean contribute to its listing as a carbon sink because all of life is carbon based? Um, no, the ocean just refers to the water itself, so it wouldn't be the same. Tara, you really need help understanding the Haber-Bosch method? Okay, so the Haber-Bosch method is basically, you don't need to know it in detail in the sense of like what exactly the actual chemical process is and how it's done on a chemical level. All you need to know is big picture. The Haber-Bosch method is an artificial way that this guy named Fritz Haber invented, in which he could extract nitrogen from the air and turn it into an ammonia compound that you could make fertilizer out of. Right? So before the Haber-Bosch method was invented, basically we had to rely on bacteria, nitrogen-fixing bacteria in the soil, to pull nitrogen out of the atmosphere to make it available to plants, which need it for growth. So he invents and figures out this way to extract nitrogen from the air artificially using this method, which you don't need to know the details of, but it allows us to make synthesize fertilizers with nitrogen so that we can grow plants faster. And so it really, really helped with the agricultural revolution in the early 1900s because it gave us a really, really effective fertilizer to give to plants and enrich soils with nitrogen and not just have to rely on the slower biological process with bacteria. So that Haber-Bosch method is really, really important if you want to think about agriculture in the early 1900s. If that makes sense. Let's see what else. I'm missing a couple questions. Now they're starting to come a little quicker. Starting to fall behind. Meenakshi, how would you fill in this blank? Intolerant organisms are blank to stressors, are sensitive to stressors, and they blank in pollution. That's a good question. So they're sensitive to stressors, and they probably like die in pollution, and then tolerant organisms are resistant to stressors, and they can survive in pollution. No problem, Shervin. Facultative organisms, don't worry about that. You don't need to know that. Meenakshi, you don't need to know what facultative is. Ryan, you got 10 more acres than a friend that had a similar calorie intake per day. I checked my answer, but I got the same results. Ryan, that might not be wrong. I mean, it depends on what your friend and you ate and how much. So if you ate more than him, and the things you ate were less, then the things you ate require more land per calorie, right? So that would mean like eating things like meat instead of vegetables, which require more land. Then it would make sense for you to need a lot more acres. So the more protein you eat from animal sources like pork, chicken, beef, especially beef, it's going to bump up your land requirement quite a bit. So don't feel like your numbers are wrong. It's fine. Danush, can you please explain the fluctuation in the graph of the carbon cycle thing? I think it's called the Keeling curve. Yes, I'll go over the Keeling curve is a good question. Nyanika, I see that you answered that. Let me see what your answer is. The Keeling curve is basically a curve that shows carbon dioxide is accumulating in our atmosphere. Yeah, so the Keeling curve, I'll pull it up. Keeling curve. Images. Boom. So the Keeling curve, what you're asking though is the actual fluctuation on a year-to-year basis, right? Right, so if you look at the Keeling curve, it shows that for sure from so when we started measuring in the 60s through today, the amount of CO2 is going up. But if you look at a year-to-year basis, which you're seeing in this like cutout part of the graph right here, the amount of CO2 goes up in the summer and spring, it starts to go up in the fall and goes up through winter and then decreases over the summer. So why does it do that? The fluctuation on a year-to-year basis is due to the amount of photosynthesis taking place. So in the winter months, October through, let's say, April, the trees don't really do as much photosynthesis because they lose their leaves and they're not taking in carbon dioxide as much for photosynthesis. And so the amount of CO2 in the atmosphere goes up. But in the summer, right, the spring, they start to grow their leaves and they start to actually take in carbon dioxide and do more and more photosynthesis. So they're pulling CO2 out of the atmosphere all summer long as they're doing photosynthesis, and then their leaves fall off in the fall and the carbon dioxide levels go up again because they're not doing photosynthesis. So that's the fluctuation in the Keeling curve. Arun, my Erlenmeyer flask. Yeah, this thing is my go-to. How do you like the color? Wow, that looks orange in the stream. It's super orange in this picture, but this is not orange. It's pink. It's actually pink over here. The coloration is not coming through right now. Tara, you were talking about what natural process is similar to the Haber-Bosch method. What would that be? Can you go in more depth about it? And Tara's just a nickname to Antara. Oh, hey, what's up, Antara? I was like, Tara, like I have a Tara. It's similar to the nitrogen fixation. So bacteria fix nitrogen from the atmosphere, right? So the process that it's similar to in nature is nitrogen fixation. So bacteria take nitrogen gas from the atmosphere and turn it into nitric oxide in the soil. And that gets converted in a couple of other steps to be available as fertilizer. So basically, go back to the, if you're still confused about it, go back to the, which PowerPoint would it be? Go back to the PowerPoint, shoot, I forget which PowerPoint it was in. It was one of the PowerPoints in the last unit. And then we went through the process like nitrogen fixation, and then you had like nitrogen fixing bacteria, and then you had these other steps of bacteria that ultimately led to creating nitrogen that's available for plants. Ryan, my friend in 5th period was telling me that you didn't tell them to remove the 0 from the yield. Yes, that's why. So yeah, I forgot, Ryan. Yeah, so what I realized after, because it was 5th period, 5th and 6th period are the day before. And so I realized after that day that there was an error on the values because everyone was getting really, really, really tiny numbers. So like I was kind of trying to figure out like why is everyone getting like 0.1 acres? It doesn't make any sense. Or like getting like 0.7 acres. So what I ended up realizing is that the values were wrong. So we changed it. And so you're fine, and I'm not gonna mark people down for their values as long as they did the calculation right. So don't worry about it. Don't worry about it, my dude. You're good. Good question though. What up, Bradley? What is an example of a negative feedback loop? I don't think Gan went over this. My boy Gan didn't go over the negative feedback loops. So a negative feedback loop is any loop in which, let's say you have a reaction, right? And you produce a product. A negative feedback loop would be where like that product feeds back and actually stops the reaction from going forward. A classic example, the one that we usually use is in ecology, and that is with, or sorry, not ecology, blood sugar. Blood sugar. So the higher your blood sugar gets, the more your body's going to respond by making insulin, and that insulin lowers your blood sugar. So as your insulin goes up, it actually negatively feeds back by causing insulin production, which lowers your blood sugar. So the more the product goes up, at a certain point, it actually starts to feed back and lower itself. So it's like self-correcting. So basically negative feedback loops are pretty common in nature because they're self-correcting. They allow things to be sort of regulated well and not get crazily out of hand. It's kind of the opposite of a positive feedback loop where things can start to like get crazy because it feeds on itself and expands itself. Charvy, no, you do not need to know fermentation. You do not. The only way, we didn't go into that detail. Yeah, Charlie, there was a little bit of different stuff learned in different classes for the last genetics unit, so just keep that in mind. And Meenakshi, yeah, that study guide packet covers pretty much everything. I'm going to be emailing out a email to you guys that includes some keys, and one of the keys is to that study guide. Dark Matter. I always like your name, Dark Matter, because it's so mysterious. It's like, do you exist? Do we even know you exist? How does NPS pollution enter the water cycle? Usually the most common way that non-point source pollution enters the water cycle is usually through like oil and trash on the roads. And so when it rains, the precipitation washes that oil and trash off into the storm drains. And we know that the storm drains go directly to like nearby creeks or rivers. And so that pollution gets into those via those storm drains and can end up in the bay at the end of the day. Ends in the bay at the end of the day. Prasanth, how do muscle cells get energy for the first 2 minutes of exercise, and how does it change as you exercise for a longer period of time? Okay, so this is talking about transitioning from cellular respiration to lactic acid fermentation / process. So basically, in the first 2 minutes, you have a lot of ATP in your muscle cells. Or sorry, not ATP, a lot of glucose or glycogen or things that can create glucose to do cellular respiration and make ATP. But after about 2 minutes of intense exercise on that muscle, it's going to burn through all the glucose that's available. And so instead, what it's going to have to do is shift from cellular respiration, where it's using glucose, to lactic acid fermentation, where it's not using glucose. And so the energy it produces is going to be less. It's going to make less ATP than it would with using glucose. And that process is anaerobic, so it doesn't require oxygen like cellular respiration does. So you're going to start off using glucose and oxygen to do cellular respiration and make a bunch of ATP, so the muscle is going to be very strong and very active. After you use up all that glucose, the muscle starts to go into an anaerobic situation where it doesn't use oxygen, it doesn't use ATP, or sorry, it doesn't use glucose, and therefore it goes through something we call lactic acid fermentation. I don't know if I'm actually saying that right. I'm not sure, but the process is something to do with lactic acid. I didn't teach that to my class. I didn't go to that level of detail. So let's see. Thanks, Arun, for chiming in there and helping out Dark Matter. Appreciate you. Appreciate you. I always appreciate everyone that helps out other people in the chat. It's good stuff. Big fan. Mahati. Hey, Mahati, what's up? Did you know that your name kind of sounds like someone's calling you their hottie? This is Mahati. You probably heard that a million times. What is the difference between a plasma membrane and a cell wall? So the plasma membrane is the lipid bilayer, basically. It's very flexible and permeable, but still keeps things from coming in and out. The other thing, the cell wall that you're talking about, that's like less flexible. It's a little bit stronger. It's more for like keeping the structure of the cell, and it's only in plant cells. So basically you have like this plasma membrane, which all cells have, and that's the thing that has like the protein pumps and the cell transporters that move things in and out. And then in plant cells specifically, around the outside of that is something called the cell wall, which is very tough, fibrous, and strong, and keeps the cell in a very certain structure. This is why plants, you know, are much more sturdy and harder than animals, because they have that cell wall. It's very fibrous and sturdy, right? So if you think of like the trunk of a tree, it's very dense, very hard. It's because of the cell walls that are there. Danush, what type of inheritance do blood types A, B, and O show? They show complete dominance, A and B are completely dominant over O, but A and B are co-dominant to each other. So it shows two types, two patterns. Complete dominance if you're talking about A and B to O, and then co-dominance if you're talking about A to B. Mr. Chang, what periods am I teaching? Oh yeah, if you came during 6th, that's Mr. Penev. Mr. Penev teaches my 6th period apes. I teach second, 3rd, 5th, 6th, and 7th. So 2nd period I teach apes, 3rd period I teach apes. I have 4th off. 5th I teach apes. 6th I teach apes, but Mr. Penev is teaching there. And then 7th I teach bio. So I got 4 apes and 1 bio. Dark matter, you don't need to worry about fermentation if you're for my class. Slaya, you want me to review the carbon cycle? Sure, I can review the carbon cycle. It's going to take me a little bit of time because it's very complex and it's a longer thing. I had a diagram up earlier. This is actually not a bad diagram here. TBH about it. This carbon cycle is pretty good. I like this diagram a lot. So the carbon cycle is basically this idea that carbon is the basis of life, right? All living things are made out of carbon at their base. That's the matter, the stuff that we're made of. And it's a cycle. So it moves around into different locations on the Earth. You can find it in a lot of different places. Pretty much almost anywhere you can find carbon. The carbon cycle is just a diagram that shows how it moves around and from where to where it goes. And so it's a complex diagram. I'm not going to go over the whole diagram. You can look at it on your own. But essentially what you kind of need to understand is that there's the fast carbon cycle and then there's the slow, or the rapid and the geological. And so the fast cycle involves living organisms, the atmosphere, and the ocean. And so carbon moves pretty quickly between them. When I say quickly, I'm talking on the order of, months to years to even like hundreds, tens to hundreds of years. It's moving between the ocean, organisms, and the atmosphere, like bing, 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 kind of cycling around pretty quickly. We call that the rapid cycle. The geological cycle, or the long-term cycle, I'm talking about carbon that's getting trapped in like sediments at the bottom of the ocean, which then can form things like rocks, sedimentary rock, and those get trapped underground for, we're talking millions of years, right? And eventually that carbon in those rocks can be released back into the short cycle, like into the atmosphere, but it requires a long time for those rocks to actually uplift and come back up to the surface of the Earth. And so in the big picture, the reason why it's important to know those two different things is because the amount of carbon in the atmosphere, the short cycle, is directly related to climate change. And so the more we burn fossil fuels, which fossil fuels are trapped underground, that's the long-term cycle, the more we release into the atmosphere. And that causes climate change. So what humans are doing is we're taking a lot of carbon that's trapped in the geological cycle underground in the fossil fuels, coal, oil, and gas. And we're digging them up, drilling them up, fracking them up, burning them, and releasing that carbon back up into the atmosphere, into the short-term cycle. And that traps heat on Earth, causes global warming and climate change. So that's kind of the gist of it. I didn't go into the details. You can look at a diagram to see all the different ways in which carbon can move around, but you should know the difference between the short and the long-term cycle and how humans are really messing around with that and causing some major problems. Bradley, are sex-linked traits a type of pattern of inheritance? Sex-linked? Yes. Yep. Ryan, how many points? Ryan, there is no final. Remember, it's just a regular unit. It's a Unit 5 test. It's going to probably be worth around 35 points. So about the same as an average test in the class. Kelly, what's the blue? Oh, you asked about the blue revolution. The blue revolution is kind of the equivalent to the green revolution, but it has to do with water. So the idea is like the access to fresh water is kind of like this thing that happened There's not an exact like time frame for it, but the idea is that the blue revolution is this idea of changing of water in different areas, the amount of water available. We didn't really talk about it. I don't think I'm going to test you on it, to be honest, because it was part of the chapter, but it's something that I'm not as concerned about as the green revolution, because this unit is more about agriculture than it is about water cycle, so don't worry too much about it for now. Sanvi, you need help with the idea of sex-linked traits. What specifically do you need help with about the sex-linked traits? Thanks for coming in, by the way, Sanvi. So sex-linked traits, like, so let's look up what we can, if I can pull up some picture here. Let's use hemophilia as an example. So here's an example of hemophilia. So just to give you a refresher on sex-linked traits, remember, a trait is determined by a gene, right? And a gene is located on a chromosome. And so for males and females, we share the same exact amount of chromosomes, right? The only difference between a male and a female in terms of the chromosomes is that last chromosome pair, the X and the Y. Right? So for all the other traits that are on chromosomes that are not the sex chromosome, it doesn't really matter. The males and females inherit it exactly the same. There's no difference. But when it comes to some traits that are located on the X chromosome, there's a difference between men and women because females have an X and a Y, have two X chromosomes. Males have an X and a Y. So that means that females have two copies of that trait, or of that gene, right? Because they have two X's, whereas males only have one copy because they have an X and a Y, and the Y chromosome is this tiny little chromosome that doesn't actually carry that same trait or that same gene. So in the case of hemophilia, the gene that is responsible for making someone a hemophiliac or giving them hemophilia is on the X chromosome. And so what that means is that in order to be a hemophiliac, a female has to get two copies of the gene that makes you have hemophilia, whereas a male only has to get one copy. And so when we do the Punnett squares and the genetics problems with sex-linked traits, we have to use the X and the Y to show that idea when we do our crosses. Yeah. If you're still confused on that, come and see me. That's kind of a tricky one to do in a stream because it might be helpful to do a Punnett square, like sit down and do a Punnett square together. So if that was not helpful enough for you, Sanvi, come talk to me tomorrow at tutorial or lunch or in class, and I'll run you through a Punnett square problem. Mr. Chang, I appreciate you coming in as the elder statesman of the group and plugging sleep. That's big. Good on you, mate. Mahati, what is recombination? Recombination is basically crossing over. It's when the chromosomes mix up a little bit during meiosis. It's what gives genetic variation. Dark matter, there are only two products of cellular respiration, right? Yes, correct. Water and CO2. Yep. Dinesh, in the genetics quiz, there was blood types A, B, and O, and I answered complete dominance. Should I have answered both complete and codominance? Yeah, to give full credit, you would need to have had both. Meenakshi, how do you know when blood types are codominant versus complete dominance? It depends. You'd have to see the, I would have to tell you. You wouldn't be able to tell on your own unless I told you what the trait looked like when you had both alleles, right? So a complete dominance would be like if I had a dominant allele and a recessive allele, all I would see is the trait from the dominant allele. It completely covers up the recessive. With codominant, there is no covering up. You have equal numbers, You have equal, they're equal, so they kind of would share. So you would see both traits appear. So if it was like a color, like blue and pink, you would see blue and pink spots for codominance. But let's say it's a complete dominant situation, and blue is dominant to pink. If I had a blue and a pink allele, I wouldn't see the pink because the blue would cover it up, and all I would see is blue. Charvy, you don't understand antibodies? Antibodies, all you need to know really is that antibodies are our immune system's way of recognizing things that we need to, that are foreign to our cells and attacking them, right? And so basically if you receive the blood type of somebody, you receive blood from somebody and it doesn't match with your blood type, your antibodies will attack that blood and cause real problems. This is why you can only get a certain kind of transfusion. Mahati, what blood types have the D antigen? If you are a positive blood type has the D antigen and so therefore would not have the D antibody. Thanks, Arun. I appreciate you chiming in with some answers. You're on point with them. Which types of cell transport require energy? Any active transport, so protein pumps require energy. Anytime you're moving things against the concentration gradient, so you're moving things from where there's a lot of them, or sorry, from where there's not so much of them to a place where there's a lot of solute, you have to push it. It requires energy because it doesn't want to naturally go that way. And yes, endocytosis and exocytosis do require energy. Negative blood type 0. Trying to see if I'm kind of missing some things. Let's see. I don't like the fact that I'm behind the chat because I feel like that makes it harder for you guys. So I'm going to scoot forward here a little bit. I might miss some things, so just re-ask. Just re-ask your question if you don't. So I skipped all the way up back to the front. So I skipped like a chunk of the chat. I like that. I skipped the old chunk of the chat, and I'm at the front now. So basically, if I didn't answer your question, restate it. And I'm going to see what's going on here up at the front. What's up, Blue? How you doing, my dude? Thanks for stopping in. This is Bio. I'm feeling good, man. Thanks for asking. Hope you're feeling good. Hope things are going good. I don't know where you're at with your final sitch over there at your distant high school, but I hope it's going well for you. Hope you're doing good. Hope you're not getting too stressed. If a cell is hypotonic to a solution, does the cell swell or shrink? It will. If the cell is hypotonic to the solution, it will shrink. Right, so let's see, don't really get the difference between mitosis and meiosis. Also, what does crossing over mean? So mitosis and meiosis, the difference, remember the worksheet we did in class, Mahati? Oh, that you weren't there for that one, but I handed it to you. You should just know that kind of the difference between mitosis and meiosis is the number of cell divisions and the purpose of them. So mitosis, the purpose of mitosis is to generate new cells for your body that are identical to the original cells, right? To repair or grow. The purpose of meiosis is to create sperm or egg cells to reproduce and create new individuals. So the cells you produce from mitosis are exactly the same as the cell that you started with. The cells you produce from meiosis go through 2 rounds of division, and so you end up with 4 cells at the end, all with half the amount of DNA as the original cell. And so that's the main difference. And crossing over is when the chromosomes mix up their genes a little bit. so that you have brand new combinations of chromosomes. So it looks like there's some confusion on the shrink versus swell thing. So let me go back to Meenakshi's question. If the cell is hypotonic to the solution, so the cell is hypotonic to the solution, that means that the solution is hypertonic to the cell. So the solution has more solutes, right? A higher concentration of solutes. Water always moves to where there's more solutes. So that means there's more solutes on the outside of the cell. So water is going to move to the outside. If water leaves the cell will shrink. So if the cell will shrink in that situation. A lot of people said swell, so it's actually shrink. Nyanika, you said swell too. That's all right. Can't win them all. Let's see. When is active transport used by cells? Anytime you're moving, Prasant, anytime you're moving molecules from where there's not so many of them to where there's a lot of them. So against their concentration gradient. Because molecules naturally want to diffuse and spread themselves out evenly. So if a cell is trying to move a molecule to where there's already a lot, like cram it into this place where there's a lot, it has to use energy, and then it has to use active transport to do that. It doesn't happen automatically. What up, PS3 Gaming 52? Can I give you some advice to make finals week not sad? To make it not sad? Is it sad or just stressful? I feel like you're using sad incorrectly here. My advice is to just relax, don't stress too much, do what you can do, and then the rest just happens as it happens. The final is multiple choice, correct? Yes, yes, yes. Yes, Nyanika, that is true. A cell will swell if it is in a hypotonic solution. But I believe Meenakshi was saying the cell was hypotonic to the solution, so the solution would have been hypertonic. Dark matter, when DNA replicates, won't there be a couple of errors in the code? And will there be a snowball effect in any way, or do they just fade away? So yeah, so when DNA replicates, on average, there's about a couple errors per time it replicates. But remember, we have a spell check. DNA polymerase will run back along the DNA and make sure that there were no errors, and it will fix them. So the snowball effect that you're talking about can happen if DNA polymerase doesn't see that error. Those snowball effects, that's what leads to cancer. So most of the time, no. The errors are fixed and good to go, no snowball effect. But on occasion, things slip. Things slip through the cracks and you get a snowball effect. And then you get cancer. PS3 Gaming 52. Also, is there a Kahoot for finals this year? Yes, there is a Kahoot. I'm going to be playing Kahoot in my class, my 7th period class tomorrow. That's our review for tomorrow. Danush, how does transpiration help get water to the top of the plant? So the way it works is transpiration is when water evaporates out of the leaf, right? So you have the stomata in the leaf, the opening in the leaf, which is at the top of the plant. So as a water molecule evaporates out of that stomata, because water sticks to itself, if you trace that, there's a line of water molecules that go all the way down the xylem of the plant to the roots. So if one water molecule evaporates out of the leaf, it basically pulls on the next water molecule, which pulls this chain up. So each time a water molecule evaporates out, it's pulling, and it's yanking up this chain of water to the top of the plant. that's pretty straightforward. If that's still confusing, look up an animation on it. Just type in YouTube something like transpiration, xylem transpiration water in plants, and you should find pretty decent stuff. Pretty decent stuff. What up, crazy psycho? That's not weird at all for you just to pop in and say hey. Nyanika, you're doing some modding, huh? Now you're getting your money's worth for the mod status. I appreciate you still modding, even though it's like you're not even involved in the class anymore as a TA. I don't even know. Oh, I can view the deleted message. What was the deleted message? Oh, Jesus Christ. Okay. Yeah, good job on the mod there. Let's see, what else did I miss? Wait, was there an extra line on the memory jog for CR products? What do you mean? Is there an extra line? I'm not sure what you're talking about. There's an extra line? Oh, like, well, because there's only like cellular respiration. Oh yeah, don't forget there's 3 products. So there's carbon dioxide. Wow, I just blanked. My brain is working on 1% energy right now. Carbon dioxide, water, and ATP. So ATP is technically a product in a way. So you gotta throw it in there. You gotta throw that in there. All right. My dark matter. You think my water looks like flesh? Ooh, my water looks like flesh? Yeah, maybe I like Oompa Loompa flesh. It's orange, dude. I'm running low on water though. All right, guys, what should I make? I'm running out. I'm gonna get some more water. What color do you want it to be? What color should the Erlenmeyer flask water be? The last one, so the orange color is gonna go away. I'm gonna put in another color. It's Trump flesh. Yeah, I'm drinking Trump flesh. Can you imagine? A Erlenmeyer flask full of melted Trump flesh. All right, some of your guys' color requests are a little impossible. Like, I don't even know what the heck cerulean means. Cerulean? Come on now, give me a break with that. Neon pink. The problem is if I make it pink, it just looks orange on the chat or on the stream. Crazy Psycho, I think I know exactly who you are. I'm not gonna say it, but I'm like 99% sure I know who you are based on what you've said so far. TBH about it. What up, Ethan? How you doing, man? Thanks for stopping in. Are you gonna still come tomorrow and bring your Switch so I can play Smash a little bit after school? Actually, I can't play after school. Shoot, I have a PT appointment for my knee. Ice Swallow come. Oh, gee, how dare you? How dare you get me with that? I'm embarrassed that I got by that. Anyway, I'm not going to answer your question. I'm not even going to answer your question now. It's not even on my agenda. It's off the agenda. Good for you, dark matter. You're an organism and you're made of cells. That's all right. Blue. I'm seeing blue. I'm seeing black. I don't want to make it look black because that's kind of weird to me. Blue, black. I think I'm gonna go. We're gonna go blue. We going blue. We going blue. I'm feeling blue. All right, we got blue on deck, and this is fresh. This is cold, fresh water, straight from the icy glaciers of my refrigerator. Is this my right earbud? I hate how they write the right and the left on earbuds so small and barely visible. No, this is the one. This is the one. Alrighty. Alright, what else? What did I miss? Any questions here? What happens in meiosis? That's a very broad question, my dude. Dinesh, what happens in meiosis? A lot of things, many things. And I can't describe them all, to be honest. It's too much. It's a little too much. The different stages, you don't need to know that, Dinesh. You don't need to know the different stages of meiosis. It's not required. We didn't go into that level of detail. Did not go into that kind of deets. We didn't go into the deets. Did not get into the weeds with meiosis on this year. Now people are just talking about flesh. Look what you started, Dark Matter. We're talking too much about flesh now. Now the chat's getting silly. I like it. I'm a fan. I'm a fan. What up, Ronit? How you doing, my dude? Neil Khan, sup? Peace. This symbol never died. Peace sign. Stuck around. Ethan, you're gonna fall asleep again? That's typical of you. Sanvi, I actually really like your little avatar thing. You have the Christmas hat on like the anonymous icon. I like it. I like it. Can I explain what hemophilia and F1 are? Well, hemophilia is a disorder in which a person's blood doesn't clot. So like if they get hit or cut or scratched, they'll just continue to bleed. It's really actually pretty dangerous disorder. It's a sex-linked trait, so it's on the X chromosome. And the F1 basically means the first generation. So when you're doing breeding, you have the parent generation, you breed them together, and their offspring we call the F1 generation. Neil Kant, yes, that was Aditya. He said not to open stream or Steam on the stream, but I've answered a lot of questions and it's kind of dying down a little bit, so I was just going to play a little bit. Crazy Psycho, I know who you are. I know, based on the attention that you're asking for, I'm almost positive I know who you are. So I'm almost positive. I'm not gonna call you out. Actually, I don't know what are your initials. I would say, can I even remember your last name? Maybe SB? What am I missing here? Let's see. Who asked if someone has hemophilia, Rayad, if someone has hemophilia and is a negative, would it be better for them to bleed or just put some A+? What? What are you even asking? I don't actually understand that at all. I already said your initials. If you missed it, you missed it. You missed it, you missed it. Did I miss a question? I think I missed a question. Oh yeah, you answered. Thanks, Nyanka, for answering Surya's question. The surface area to volume ratio gets smaller as the cell gets larger. Thank you. That's true. It's true. Nishat, I think Miss Lerner is one of the best teachers on campus, actually. If I'm being honest, I really do. She knows way more about biology than I do, and she can teach it way better than me as far as her technique of teaching. It's pretty impressive. Alright, let's see if I can play this game a little bit. Problem joining the lobby. Refresh. Meenakshi, there's no extra credit opportunities. Ooh, there's a chimp, a little monkey. I want to be the monkey. No extra credit. Let's do the pyramid. Dark matter. So males are more likely to get a sex-linked disease because they only have one X chromosome, while females have two X chromosomes, making them to be more likely to be a carrier. Correct. Yep, that's exactly right. Males are more likely because they only need one copy, whereas females need two. Yeah. What's the goal? Where do we start here? Shoot. Oh, he won. Will the final be more difficult or the same difficult? It's probably the same difficulty. Probably the same difficulty. Crazy Psycho, I know, you're in 6th period and your initials are SB. I guarantee it. Alright. My B. Why is cancer dangerous? Good question, Kelly. Why is cancer dangerous? The problem with cancer is that when you have a cancerous cell, like a tumor, for example, or a cell that becomes a tumor, that forms a tumor through cancerous process, its main issue is that it starts to affect the surrounding tissues negatively. So imagine that you have, let's say, cancer in your liver. So what happens is that tumor gets larger and larger and larger, and eventually the liver is not going to be able to function correctly because that tumor takes up quite a bit of its resources. Dude, does that make sense? So the cancer actually just hoards resources from the functioning organ. Where is the thylakoid disc located? The thylakoid disc, where is it located? It's located in the chloroplast. Ah. Where does that transporter go? Ethan, do I want to join your fight? I'll be in my room at lunch if you want to stop by. I'd be definitely down to play a little bit. Arun, I'm not going to play Fortnite tonight, I decided. I don't think I have enough time. What time is it? Yeah, I'm going to stop in about 20 minutes, so I think what I'm going to do is just stick with Ultimate Chicken Horse for today. But maybe I'll play Fortnite during finals week when I have a little more time, like a casual stream on Twitch or something. How does that sound? Oh my god, Crazy Psycho, you are Crazy Psycho. Oh, I like you. I like you. Obsessed. Am I the last one alive right now? I like all my students. Just right now. Arun, my Twitch is just Mr. Jones MV. There's a link in the description on the video, so you can just click on that. What up, Doge? Dogecoin? Surya, what does the thylakoid disc do? I don't know, man. Actually, that's not true. I do know. I haven't taught it in a while, though, because I've been ignoring the details of photosynthesis. I believe that, wow, it's crazy how stuff disappears from your brain as soon as you stop teaching it. It's insane. Thylakoid disc, if I remember, that's the part where you have the that's like where the membrane is, right? Oh my god, I'm sorry. The thylakoid disc. Yeah, I think that's where the chloroplast is located, or the chlorophyll is located. and that's where most of the photosynthesis happens. I think. Man, it's rough that I can't remember that. I feel kind of bad about it. Let me look it up real quick. Yeah, so the thylakoid disc has membranes in which photosynthesis takes place on. Dude, Why? I'm having such a hard time. Yeah, as you guys can see, I'm kind of I've entered the casual mode of the stream after 9 p.m., so I'm kind of a little bit off some of your questions. So we having a Smash party tomorrow at lunch in B111? Is that what I'm getting a sense of? I'm in. I'm looking forward to it. Nice, I'm in. I do have a couple people that I have to help at lunch tomorrow, doing like some retakes and some test corrections and things like that. But I will be definitely... Oh, what just hit me? What was that? Oh, I got hockey pucked. Got pucked right then. Charvy, what's the Amoeba Sisters? I've heard of that before, but I actually don't know what it is. The Amoeba Sisters. Sounds familiar. Starscream just killed us all with his skills. Alright, let's see. What are we gonna play this time? Oh, ended the game. Oh my god, ended the game. Alright, Crazy Psycho, you and me are gonna have a talk tomorrow. Big time one-on-one coming your way. Thanks, Yannicka. Appreciate you. You can deny it all you want. I know who you are. Find a public game. Oh, not just full. Can't join any of these games. They're all full, or they're in the match progress. That's annoying. Ansh, you want me to stream on Sunday? It would really help us. I mean, I could try. I don't know. I can't promise. How about this? I can't promise it, but I will try. I'll send an email out and I'll post on my Instagram if I do. So if I do stream on Sunday, I'll put an Instagram story up saying that I am. Are those Instagram stories helpful when I say I'm going to stream? Do enough of you guys follow me on Instagram to actually get that message? Because that's what I've been doing. It's been my technique. I'll mention it in class, but sometimes I forget to say it in class. So I just put it on my Instagram as a story. My Instagram is Mr. Jones MV. Mr. Jones MV. Dark Matter. What will we do in class tomorrow? I'm gonna play some Kahoot in class, for sure. Bradley, I don't follow that my Mr. Jones account. I don't follow back. I just follow all like the Monte Vista stuff. So like I'll follow like the sports teams, the dance teams, like the drama thing, like the clubs and the school group things. I'll follow, but I don't follow individuals with that account because what I want that account to be for me is I want to be able to see like what people are posting that are related to the school, and not necessarily just individuals. I mean, obviously, I use it to get the word out about streams and other science stuff and just whatever. Looks like I have a lobby like match full. Dude, oh my god, that's so bad. I land like right on. I made this so hard for us with that crossbow. What? How did he not die? Oh my god, I hacked. What was my favorite and least favorite class in high school? My favorite class, I really liked photo. Photo was an awesome class. I just had fun going around and taking pictures and being creative, so that was probably my most fun class that I liked the most, just on a day-to-day basis. My least favorite class? There are some history classes I had that would just knocked me unconscious, to be honest. Straight snoozed me. But the weird thing is I love history now. Like I'm fascinated by history. But there were some moments where I was... Oh, I wanted to beat that guy. So close. Alright, looks like I got, maybe I'll play another 10 minutes and then I think I'll be out. Oh! Arrow to the face. Alright, I'm losing big time. I'm last place. Alright, this is unacceptable. Let's do this. Oh, you know what I've been forgetting? I've been forgetting to press shift, which boosts your speed. That's been stupid of me. That's been a real bad move. What are you guys even talking about in the chat right now? People are apologizing but and not accepting apologies and firing each other. I don't even know what this coin is for, but I'm gonna lay it down over here. Oh, there we go. Big time. Boom! That shift button is huge. Just got me. Too easy, no points? What? The one time I win, they say it's too easy, so no points? That'd be like if I gave a test to the class and everyone got 100% on it, and I was like, it's too easy, it doesn't count. I just got... Oh, I got nailed off the cliff there. Bye, Meenakshi. Thanks for stopping in. Nice to see you. Bye, Ansh. Nice to see you. Thanks to everyone for stopping in tonight. It was a nice little stream. It was a manageable stream. It was a good stream. It only got up to about 30 people at most. It wasn't those crazy 50 to 60, 70 people streams where it's just non-stop action. It was a good stream. Surya, what's the difference between ADP and ATP? ADP is the form after ATP has been used, like the energy has been extracted from the bonds of the ATP. So ATP has 3 phosphates attached to the end. When the energy is released to be used by the cell, one of the phosphates flies off and it turns into ADP. So it stands for adenosine diphosphate, that's ADP, and adenosine triphosphate. And then you can use ADP and recharge it and put a phosphate back onto it, and that creates a ATP molecule again. Slayer, you want me to stream during the weekend? I will do that. Well, like I said before, I can't promise that I'll do it, but I will try. I don't have time on Saturday. I'm pretty full. I'm actually going to go watch Mr. Penev get his brown belt promotion on Saturday. So actually big props to Mr. P getting that brown belt. That's pretty high status in the jiu-jitsu world. That's real high quality. Real tactician, real master. And then I'm going to hang out with Mr. H. We're going to play some PS4 together. He got Madden and he wants to play me in Madden, and I'm going to destroy him in Madden. It's going to, honestly, it's going to be straight murder. Oops. Like, I think one of you guys should call 911 and say, and report a future crime of murder, because it's straight up happening. Penev did evolve, Doge. He evolved to brown belt, from purple to brown. So I'm gonna watch that promotion tomorrow or Saturday. But Sunday I might stream. Sunday I might. We'll see how I feel, what the timing is like. There's so many people getting sick around me that I feel like I'm gonna get sick. And I just have a feeling, I got a premonition. Mr. P got a sinus infection. My roommate's sick. She's gonna get me sick. I bet, I guarantee it. One of you guys are gonna get me sick. Oh my god, I'm terrible. Neil Conf, what is my favorite NFL team? So you're gonna, Every time I say this, I get a lot of looks, but it's the New England Patriots, and I'll tell you why. It's because I lived in Vermont. I grew up in Vermont from the ages of 0 to 12. And so Vermont, that's where, that's New England. And so I grew up watching the Patriots, and I was a Patriots fan, so I stuck with it. I'm not a bandwagoner. I'm true. Tried and true. Oh, I got lucky right then. Big time lucky. Sanvi, you're almost a brown belt? In what? What are you a brown belt in, Sanvi? That's kind of cool. I didn't know that about you. See you, Dark Matter. Oh, Dark Matter, you're Vasant? Putting it together. I'm putting 2 and 2 together here. Bye, Surya. Okay, Vedant. You can't. I don't think there's any argument that Brady isn't. Brady has to be the greatest of all time. Like, there's no argument against that. Just his credentials, his stats, his longevity, his Super Bowl dubs, his MVPs. It's pretty tough. Oh, I got rejected by that block. No, Vedant, you're wrong. It's not Montana. Ain't no way it's Montana. Compared to Brady, you're insane. Oh, great. I should just straight up ban you, Crazy Psycho. Ban you from the chat. The Niners. It must feel bad to be a Niners fan. All the time, every time. That's why I feel bad for Mr. H. He's a Niners fan. Alright guys, I'm gonna play one more game and then I'm gonna call it quits for the night. What time is it actually? Yeah. One more and then I'm done. I don't know this one. The goal is down there. You start here. Does this water knock you down? Oh my god! So close. Alright, this time I got it. Oh, we get more stuff. I want to knock people down with this thing. So if you're trying to make this move. Ah, I got killed by my own trap. As usual. That's classic. It's classic. It's classic me. The problem is it's not my favorite. I don't teach that period. You know what I mean? I mean it's a good period. I just don't. I'm not as involved. Oh my god. Oh. Dude, this guy with his what is that? Is that Chinese? This guy that's winning. I don't really have a favorite period. Actually, you know what my favorite period might be this year? It might actually be bio, 7th period bio. You guys are just crazy. You have so much energy, but it's always on task. It's very positive. Actually, I'm a huge fan of my 7th period bio. Oh my god, I'm not paying attention enough to the game, to be honest right now. I'm getting destroyed. 7th period bio. You guys have been, you probably are my favorite. I'm gonna be honest, so far, after one semester, if I'm assessing it, you might be my favorite bio period I've ever taught. Straight up, no lie, no joke. Very strong period. A lot of very interesting personalities. It's good stuff. Just wait, Charvy. It's gonna happen at some point. Dude, I get so nervous. I get like jittery. I like jump around too much in this game. Alright, Arun, what's your question? Fire away. Do I think Penev is a good teacher? Absolutely. Mr. Penev is... good stuff! Mr. Penev is what, you know, if you think about student teachers, he's extremely unflappable. That's what Miss Lerner said. He's very unflappable. He takes things in stride, very confident. Which is unique for someone who's sort of entering that kind of a profession where you're standing up in front of people. But he's old. He's not like super young, like straight out of college. So that gives him a bump up there. But yeah, I do. I think he's good. I don't know if I want to play another game. I think I'm good to go on this one. I don't really have favorite students. That's not true, I do. But I'm not going to tell you. Arun, did you ask your question? What is G1, S, and G2? So G1 is the first growth phase during interphase where the cell is growing. S is the synthesis phase, so its DNA replicates. G2 is the cell gets ready to divide, and then it goes into mitosis and divides and then goes back. G1, S, G2, mitosis. G1, yeah, growth phase, synthesis, growth 2. Kelly, does cellular respiration happen in the leaf of the plant? Yes, cellular respiration happens pretty much in every cell of the plant because it provides ATP. Alright, I'm going to call it quits here for the night. I think it's time for me to wrap it. Put a wrap on it. Yeah, I think it's a good to go. Arun, I answered your question, brat. Didn't I answer it? Oh, wait, you had a second question? And meiosis would replace mitosis for the creation of gametes? Yes, that's correct. You are correct. So why do I like, what are my most interesting personalities in 7th? It's hard to, they're just a bunch, they're all different. It's just an interesting mix. It's a very group of students. They're all freshmen. This is freshman bio, by the way, so you probably wouldn't know them as much because they're freshmen. But they're a good mix of students. They all get along very well. They sort of all have their own uniqueness, and they're very enthusiastic, which makes it sometimes tricky because I have to be like, all right, guys, we need to focus here. We get the side conversations are a little strong, but usually they focus up, which is good. You know, it's good stuff. All right, guys, it's time for me to call it a night, and I'm out. Appreciate y'all. Peace be with you, and I hope everyone gets some sleep and that you eat well, sleep well, and don't over stress yourself, because that's going to lead to some not such good things in the next week, and then you're going to be sick. You're going to get sick for Christmas break, the holiday break. Sorry, I don't mean to be uninclusive of all the different holidays, but the holiday break, you're going to get sick. You're going to not enjoy it. So don't overdo it. Drink some water. I will see everybody on the flip side. Peace. Love y'all.